Knock on wood. Okay. All right. Okay, next one. Let's go to the next section. Good morning. If you're just joining us right now, we are in Delta Math, and we are now moving on to our fourth question. Yep. What is the greatest common factor of 24 and 48? So you look for the smaller number, which is 24. Can 24 divide 48? Yes, Nyla, you got it. Let's go. All right. Next number, 46 and 16. So start with the smaller number, 16. It doesn't go into 46, so count backwards. 15, 14, 13, 12, 11, 10, 9, 8, 7, nope, 6, 5, 4, 3. We got no choice. Both are even, so 2, right? Okay, so these are the possible factors right there, and 2 is the highest possible, highest common factor. All right, let's do it again. 50, 42, and 30. Okay. My kindergarten's computer is too loud. Okay, 50, 42, and 30. If it bothers you, let me know, okay? I'll try to use a headphone. Okay, 50, 42, and 30. 2. All right. Any other answer? I'm gonna go with 2. Cross our fingers. Yay! Good job, Brian. All right. Yeah, the 42 kind of threw me off, right? Because 42, it's not divisible by 10, Yeah. Okay. Cool. All right. Let's keep going. Greatest common factor of 36, 34, and 22. So you can't have a number, you can't have a GCF bigger than 22. 2 again from Brian. Let's see. All right, very good. Okay, so can you guys try to finish this? You have 3 more while I prepare your Kahoot window, okay? All right, so finish that, Delta Math, and I'll just get ready with our Kahoot. All right, did you guys finish? Can you type in the chat pod what your scores are? $100%! That's great! That's awesome! Okay, so I'm also, okay, here we go. GCF. Alright, so let's play Kahoot. Resume. Okay, you guys ready? It's gonna be on GCF again. Alright. Classic. Alright, here we go. Waiting for players. All right. Oh, there's echo. My bad. Excuse me. Okay. Is it okay if there's no more music? I had to turn off the sound of the other one because there's echo. Okay, whenever we're ready, let's go. Let's get started. You can join anytime. Here we go. 40 and 48. Answer quick. 5, 4, 3, 2. All right, next. Ooh, I did not expect that. Some of you answered green. Yeah, 4 is a factor, but you have to pick the bigger one. It's okay, let's keep going. Bald Rooster, you're first. 10 and 45. 10 and 45. 5 seconds. All right, skip. Ooh, nice one. Next. And still. Old Rooster. Next. Here we go. 10 seconds. 5, 4, 3, 2. All right, let's go. Ooh, I did not expect that. So 21 and 40. Yep. It's 4 times 10, 7 times 3. So if they don't have a what do you call this? A common factor greater than 1, the answer is 1. We don't say 0. It's 1. Yep. Okay, next. Ooh, Nimble Rabbit. Let's go. 60 and 72. 7, 6, 5, 4. All right, skip and let's see. Oh, all right. Next. 7, 6, 4, 3, 2. Skip. Oh, wow. That's an even split. So 28 and 32. Oh, 8 doesn't go into 28, right? Okay. Let's go. Next. Oh, I didn't see who's winning. 28 and 49. 5, 4, 3, 2. Skip. All right. 7. And who's winning so far? Nimble Rabbit back on the lead. Okay, a few more. Here we go. 12 and 36. Oh, look at that. That's a scary. What's that? Tarantula? Bug? What's that? All right, skip. Here we go. Oh, all right. 12 times 3 is 36. Still Nimble Rabbit. Let's go. 15, 32. All right, let's go. Ooh, just one answered differently. And still undefeated. Okay, here we go. 9 out of 10. Oh, that's so cute. It's like Wilbur. 16 and 24. Let's go. Oh, wow. 16 and 24. What's the other famous answer? 4. Oh, okay. Oh, 6. No, 6 doesn't go. Yeah. What's the blue one? Yeah, 4 doesn't go into. Oh, it goes in both, but it's not the highest possible one. Yeah, it's 8. Okay. And alright, alright. Okay, one last, right? Ooh, now it makes me hungry. Bacon. Bacon. Alright. So can you guys reveal who you are before we show the winner? So in the chat pod, can you reveal who you are? If you win, you get a Schoology badge. Oh, alright. Alright. Okay, let's see. And here we go. On the podium. You see your name, type me. Social B. Alright. And the winner, Nimble Rabbit. Still generating nickname? Oh no. Alright, you guys. That's awesome. So Nimble Rabbit is Brian, right? Did I remember it right? Yes. Awesome. Okay. You get a Schoology badge later on, honey. Okay, so we're gonna use what we learned about GCF to actually learn how to factor today. Factor polynomials though. So what makes polynomials different is that they now have some variables in them. So on this, go back to your OneNote. On this OneNote page, we will have some classwork and at the same time some extra credit as well. All right. So go ahead and open that page. So there's a lot of problems in here. You see that? All of it. And all of these are different kinds of greatest common factor. So I will give you until next week to finish all of them. Put it on a piece of paper or put it in your OneNote. It's up to you. It doesn't matter to me. If you do it on paper, just take a picture and either you paste it in OneNote or send it to me via Remind. We'll go over some today, okay? And then you guys will finish the rest, okay? So let's get started. What's the very first or the most basic common of GCF problem for polynomials? So I have here different kinds of expressions. So let's start with something that don't have a number. Let's say x squared and negative x to the sixth power. If you're looking at variables, okay, so the greatest common factor for variables is normally the lowest exponent. Lowest exponent. Because you're looking for that, highest possible power that is shared by both expressions. So if this is x squared and this is x to the negative 6, right? So what is the lower power between the two? Definitely it's x to the second power. So that's the most that the other one can also have, right? So the GCF here will be x to the second power. So similar to when we were doing the numbers earlier, you look for the lowest number, right? Between what's given, and then you start counting backwards from there. So same thing here, look for the lowest exponent. So using that as an example, can you give me the answer to number 2? If you have t to the 4 and t to the 7, what's the highest power that they both have? What's the most amount of t's that both of them have? Excuse me. Anyone? The GCF must be the variable with the lower exponent, 4. Very good. So t to the 4. So you're only looking for the lower power. That's it. Okay? Let's try again. 2x squared and 12x. This time it has numbers. So you're going to look at the numbers first. What's the GCF of 2 and 12? What's the GCF of 2 and 12? 2. Perfect. Oh no, what happened? Okay. Oh, really? Not again. Okay, so the GCF, can I write here? Hang on. Okay, share screen. All right, honey. I hope you feel better. I'll text you later. Okay. Okay. Hang on. My other device got disconnected again. Let me see if I can pull it up over here. Oh no. Okay, well, while waiting for me, go ahead and look at those examples. And okay. Yep. So just look at those first set of examples while waiting for me. And I'm trying to... So always look for the lower power of the variable. But for the numbers, do what we did earlier. Like you start with a smaller number and see if it can divide the other. If not, you go backwards. Okay. So period 1 starts. Okay, I'm gonna back up. Okay, I think I'm back. All right. So as we were saying earlier, you are muted. Okay, so which one has, or this one has sound? Okay, so as we were looking at this one earlier, you said the GCF of 2 and 12 is 2, right? Okay, now what about the variable? So look for the lower variable and exponent. So there's only one variable, it's only x, so we got no choice, right? Just x. And the lower exponent is 1, so it's just going to become 2x. Okay, how's that? So you get the GCF of the number, and then you get the GCF of the variable. Okay, can you try number 4? So what's the GCF of 36 and 18? What's the GCF of 36 and 18? Even if you're not sure, type in the chat pod 18. Okay, that's great. That's actually correct because 18 times 2 is 36. Yes. And then get the lower power of the variable. So what's the lower power? The lower power is 3. Perfect. Very good. All right, so 18x to the third power. Okay, let's try something that has two variables. And what if it has a negative like this? If it has a negative, you gotta pick the positive GCF because it's greatest common factor, right? Okay, let's pick something that has, oh, look at this one, number 10. So what's a GCF of 5 and 10? What's a GCF of 5 and 10? And type in the chat whether you're sure or not, because it keeps us going instead of, 5. Perfect. Okay. And then look for the common variable. So common variable means they have to have that variable, like both expressions. So the first one doesn't have an x. So we're going to leave x alone. We're not going to put an x in the answer. But they have y in common. So we're going to pick y and get the lower number for y. What's the lower power? The lower one. Very good. Okay, so if the other one doesn't have x squared, ignore it. Okay, so can we try, let's try 11. 11. Let's look at the numbers first. 28, 14, and 42. So the lower number is 14. 14 goes into 28, but does it also go into 42? I think 14 times 3 is 42, isn't it? So our GCF is 14, yeah? Okay, can you tell me what powers I'm going to use? What variables and powers I'm going to use? A, very good. So A to the second power, because that's the lowest exponent of A. The middle one doesn't have a B, so don't use B for the GCF. Great. Now what if they look something like this, like number 2? So the GCF of 2 and 3 is just 1, right? Yeah, because 2 times 1, 3 times 1. So if it's 1, you don't have to write 1 unless it is the final answer already. Just like earlier, we had to write 1. So the GCF of 2 and 3 is 1, or I should write it because you might get confused. Now, x plus 3 and x plus 3. So definitely x plus 3 is shared by both, right? So if both of them have x plus 3, then you're going to write x plus 3. So if it's a binomial, you don't separate them. You treat them as a group. You can't separate from one another. So 1 times x plus 3 will just become x plus 3. So that's the time you can erase the 1. Okay, so with that as an example, what's the answer to number 14? What's the what's the answer to number 14? So 14 and 3x, I don't think they have anything, right? Yeah, it's just 1 again. But look at the binomial that they have, x minus 5. So yes, that's the answer, x minus 5. Okay. All right. So I'm going to skip some of those and then move on. So whatever we didn't finish, you guys have to finish. So at the end, at the end, some of these will be extra credit. I don't give a lot of extra credit, but this topic is really important. So you get 68 points. Okay, here we go. So 17. What if they now separated by plus or minus in between? So earlier they were just individual expressions, right? So if they now have plus or minus in between, we're still following the same procedure, but we're gonna write the answer differently. So say for example, what's a GCF of 3x and 3? So what's a GCF of 3 and 3? Definitely it's gonna be itself, right? So we're gonna divide each of them by the GCF. Sorry, it's too small. Maybe I should write it. I should write it somewhere here. Okay, so I have 3x plus 3, right? So first think of a number, which is the GCF of 3 and 3, so we know that is 3, right? Okay, so now we're going to divide that one. And how do we write the answer? You have to write it as follows. So 3, that's the GCF, and then the leftover, or the answer when you divide each of them by 3, you're going to put it inside the parentheses. Okay, so 3 divided by 3 is 1. 1 times x is x. And then 3 divided by 3 is 1 again, but there's a plus sign, so plus 1. So what are we trying to do here? What we're trying to do is, we're trying to find the two things that were multiplied by distributive property before they got this answer. So they're working backwards. Last meeting, we were talking about multiplying polynomials, right? But now we're undoing the multiplication. So we're factoring them. So if you distribute it backwards or multiply it back, 3 times x is 3x. And then 3 times 1 is also 3. Okay? So this one will become 3 times x plus 1. All right. So now can you try number 25? 25. 24y squared minus 18. So give me a number that can divide both of them. What's a number that can divide both of them? 24 and 18. 6. All right. Okay, so 24 divided by 6, that's going to be 4, right? Y squared. 18 divided by 6 is 3. So your answer will be, you write down the GCF, do not lose the GCF, and then you put the answer after dividing them. So how do you know you're right? You multiply it back. 24y squared and then negative 18. Okay. Now what if, I'll show you something. What if you didn't know that 6 is the GCF? Okay, so look what's going to happen. Suppose I just thought that it's 3. Do I get it wrong? Well, let's try. 24 divided by 3 is 8. And then 18 divided by 3 is 6. So this is how it's going to look like. What's going to happen is that 8 and 6 will still have a common factor. So you can continue working from there. You could say, oh, I can still divide these by 2. Yeah, so now you multiply here by 2, right? Because you divided here, that's another GCF. So you get 6 now, and then 8 divided by 2 is 4y squared. 6 divided by 2 is 3. So you're still going to end up with the answer that we got when we divided 6 the first time. Okay, so if you didn't get the GCF right the first time, you would see when the numbers are smaller that they can still be divided further. Okay, let's try. What if I want to try 29? There you go, 29. 25u squared minus 14u. Do 25 and 14 have a common factor? Or is it just 1? It's 1. Good. Okay. Now they both have a variable, u squared and u. So what's the lower power of u? What's the lower power of u? Just 1. So u. So your GCF will be 1u or just put u. Okay? All right. Let's try trinomials. Let's go to 39. 39. Okay, so 12, 16, 8. What's their GCF? What can divide all of them? 4. Yeah? 4 works. Okay. Now, what do you call this? Oh, wait, sorry. I didn't finish number 29. After getting the GCF, I forgot to write down the answer in parentheses. My bad. Okay. So you said U. And then what's the answer after dividing by U? So you take out 1U from here, you're going to get 25U, right? You can also do that. Once you get the hang of it, you can just do everything in your head. You don't have to do this part that I'm doing right now. But sometimes it helps students, especially when they're very visual. Like they see, oh yeah, I'm removing 1U from there, so I get 25U left. Okay? But you don't have to do that step. Okay, when you're very, very good at it already, you can just do it in your head. So going back here, the GCF is 4. So now you're dividing each one by 4. You're dividing each one by 4. So there you go. All right, so what will be the first factor over here? 12x squared divided by 4 will become 12x 3x squared. Very good. Okay, plus 16x divided by 4 becomes 4x, and minus, what's the last one? 2. That's perfect. Okay, cool. How are we doing in this one? Okay, can you try 45 and 46? I'll give you about 3 minutes. Try 45 and 46. And then we'll look at another type of GCF. Yeah. 45 and 46. I don't normally teach all these types of GCF to my regular classes, but you guys are, your algebra is a pre-AP algebra, so you have to like dig deep. Okay. 2 more minutes. Try 45 and 46. And if you find me too slow, find something else that you want to do. And if you have other questions, let me know as well. But for today, we're just gonna like look at some of all these examples on that page. And your extra credit is to like try all of them. One minute. Okay, whenever you're ready. In the chat pod, tell me what's a GCF in number 45. 5. Perfect. Variable. Variable. U. Perfect. So the GCF is 5U. Next, give me the answers. So what's the first one? You're supposed to give me a trinomial inside the parentheses because there were 3 originally. So divide each one by 5U. What do you get for the first term? So what are we doing now? We're dividing every single one by 5U, right? So don't stop at finding the GCF. You gotta write down as well. Okay, that's great, Brian. U squared plus U plus 1. Perfect. So that's why I chose that problem, because common mistake, students just leave the third place blank. So it's not 0. It's 5U divided by 5U is 1. Because if you miss that and you multiply that back in, you're not going to have a third term. Yeah? So remember, to double check your answer, you got to multiply it back in. Okay, next, 46. What's the GCF? Oh, can I erase all the ink first because so I can scroll it up. 46. What's the GCF in 46? Both number and variable. Both number and variable. Okay, so now my other ones got disconnected. Can you hear me? Can you hear me from this device? Is my other one? Okay, cool. All right. Thank you. Okay, I'm gonna stay on in this device. Here we go. Number 46. So what's a GCF? 11, negative 22, positive 11. So what's the GCF? 11. Perfect. Variable? Variable? Why? Good. Because that's the lowest power. Perfect. So now let's divide everything by 11y. If it helps you, you can put the 11y under, but it's a good practice to not put it, you know? All right. So first factor here. 11y cubed divided by 11y, what do you get? Cancel the numbers, subtract the exponents. y2, perfect. Minus, minus y, are you sure? 2y, there you go. Minus 2y, because 22 divided by 11 is 2, right? Y squared divided by y is y. Plus, don't forget the last one, plus 1. Perfect. Okay, so that's, I know GCF has a lot of forms, and I'm trying to like exhaust all those possible forms with you. Okay, so let's keep going. Here we go. All right. So here, for the third type, you can factor out a positive GCF and a negative GCF. Of course, when you say GCF, it's greatest common factor, right? So we normally just pick a positive one, but here we're just going to practice taking out both positive and negative. So we have to factor it 2 times. So how do we do that? Let me copy the first one here. 5 minus 10x. So we're going to split that, right? The first one is, excuse me, we're going to divide by a positive GCF. So what do you think is a positive GCF for 5 and 10? What's a positive GCF for 5 and 10? 5, very good. All right, let me just open the chat again. Okay. So if you factor out 5, what will be the remaining factor here? So what's 5 divided by 5? 1. Minus, what's 10x divided by 5? Try again. Excuse me, negative 10 divided by 5. 2, okay, good. Minus 2x. So the other one is, let's try another one, but this time we're going to use a negative GCF. So you will divide each one now by a negative. Okay. So how will that affect your other factor? So negative 1, perfect. And then what's negative 10x divided by negative 5? Plus 2x, perfect. So later on, when we factor polynomials that have 4 terms, this will be very useful. Yeah, so this technique will be very, very useful. Okay, let's try one more. Look at number 57. It says the only positive common factor is 1. So for this problem, just do the second part by factoring out a negative 1. So in other words, for 57, you have negative x squared plus 5x plus 10. It's just asking you to try to factor a negative 1. So if it's negative, we normally write negative 1, but you can actually just write negative in front of the parentheses. Okay, so let's see what's going to happen if we factor out or we divide each term by negative 1. What's the first term? Excuse me. So negative x squared divided by negative 1 is positive x squared. Perfect. 5x divided by negative 1 is negative 5x. Cool. 10 divided by negative 1. That. Oh, sorry, Bixby. Okay. 10 divided by negative 1 is negative 10. There you go. So that's going to be negative parentheses x squared minus 5x minus 10. So we don't normally put the 1 anymore. Okay. All right. And same is the case for number 56, right? Okay, I want to show you an example of the last kind at the bottom so you'll know how to do your. Now your extra credit is not due until next Monday, okay? So don't stress yourself out finishing all of these in one night. If you can, good for you. Okay. So here we are going to factor out a, what do you call this? A binomial. A binomial. Binomial means 2, right? Okay, so I'm going to try number 61 over here. X parentheses x minus 3 plus 5 parentheses x minus 3. So if you take a look at the quantities outside the parentheses, x and 5 don't actually have a greatest common factor besides 1, right? But if you look at the binomial that they share, it's x minus 3. So that means a common binomial factor is x minus 3. So we're going to take that out. Yeah? Okay, we're going to take out x minus 3. And then after that, remember, every time you take something out, you're dividing each one by that same factor. So if you divide x minus 3 by x minus 3, what's your leftover? What's the factor left here? They cancel out, so what's left? This turns to 1, so x times 1 is x. Perfect. Now we're going to do it again here. So x minus 3 and x minus 3 was already factored out, so we divide, that's just 1 plus 5. Very good. So 5 times 1 is plus 5. So be generous with your parentheses. If I just put x minus 3 without a parentheses, and then I put x plus 5, this means the 3 is the only one being multiplied inside, right? So that's a different scenario. So be generous with your parentheses. If you're not sure, put it in parentheses. Okay, let's try another one. I want to do something that has like a rearranging thing. 68. Okay, let's try 68. Okay, for 68, you have y squared x minus y minus 4 y minus x. So if you look at the things inside the parentheses, they look similar, but not exactly. Okay, so you have to make them match. So how are you going to do that? You switch these around. Okay, but how do you switch it around? You have to remove the negative from the x so that it will become positive x. So what is it doing over here? It says you factor out a negative one to make the binomial match the other, right? So let's do that. Y squared x minus 1. Originally you have a negative 4, but now you're factoring out a negative 1 again. So in other words, you're dividing these by negative 1, negative 1. Okay, you see how they just switched the sign in the 4 from negative to positive? Right, I'm just showing you here how that happens. So if you divide this, y divided by negative 1 will become a negative y. So I'm now rearranging them so it will match the first one. And a negative x divided by negative 1 will become a positive x. So now that they match, these negative here will change the 4. And I showed you this way because sometimes what if there's a 2 in both of them? Then that means it's not just 1. It could be a 2 that you have to take out, like a negative 2. Alright. So in that case, you have y squared x minus y. Negative 4 times negative 1 will become positive 4, and then x minus y. So can you give me now the final answer? The common binomial that you have to bring down is, so bring this down because that's common, right? So x minus y, and then what are the leftovers when you take them out from each group? I call them the outliers, So what are the outliers? Which ones are left outside the parentheses in both terms? So what are they? You took this out, right? You brought that down, you brought that down. So what are the outliers left? Okay, if that didn't make sense, remember that we're dividing both of them by x minus 4. Oh, there you go. Okay, so that means they cancel, and now you're just copying the outliers. Nyla said y squared plus 4. There you go. Uh-huh. So yeah, if it doesn't make sense when you don't divide them like physically like this, like go ahead and divide them if the visual, representation helps you. Yeah. But once you get the hang of it, you can just do it in your head. All right. So for your practice, I showed you all the different types of GCF over here. We will be using these techniques throughout this chapter. And this chapter is short, but I normally spend extra 2 days in this chapter because this topic is heavily, tested, or if there is no testing, you will need it all the way until you go to pre-calculus and calculus. So we need to focus on this one. All right, you guys. So for your extra credit, it's due Monday. It's extra credit, so no late submissions, please. You gotta do everything on this page. So that's how much points? That's about 60 something. Yeah, 68 points. Okay, you can write down the answers. I'll probably like take away 10, 15 points because I answered some of them, right? Um, you will be turning this in by taking a picture of your paper, and you can make a new page here. You add a new page and paste it, or just send it to me via Remind and I'll take care of that as well. Any questions, guys? Any questions? So for your homework, I don't think you need to worry about giving your homework if you have enough to do this week. Okay? All right. I will see you again on Thursday. I hope you guys have a great day. And if anything, text me. And don't forget to share my Google Voice number with your parents in case they want any parent conference, or there's family emergency and you can't log into Zoom. Did you sign in? I didn't have the time. Did you sign in? Okay. Well, I'm gonna send this again to via Remind. So okay. Thank you guys. You guys have a great day. Bye bye. Adios.